Hello, I'm John Clark. I'm a professor of astronomy at Boston University. I was trained to build instruments for ultraviolet observations of the other planets and their atmospheres. I worked for NASA when I was younger, working on the Hubble Space Telescope project before it was launched. And since then I've used the Hubble in part to study the giant planets, Jupiter and Saturn, and observe their auroral emissions, like the northern lights on the Earth. More recently I've become interested in Mars and Venus, and I'm still using the Hubble. One of the main questions about Mars and Venus today is what we call the Goldilocks problem. Today Venus is too hot for life as we know it to exist, and Mars is too cold and the Earth is just right. We would like to understand how three relatively similar planets have evolved over time to such different conditions today. As an example of this, I'm showing here two images, a Hubble image of Mars on the left and the simulation on the right. This is an ultraviolet image of Mars showing hydrogen emission from the upper atmosphere, hydrogen atoms reflecting sunlight. And you can see that they're extending way off into the space around Mars. We think that part of the explanation for this is that Mars has a relatively weak gravity, being much smaller than the Earth, and it's about 1.5 times as far from the Sun as the Earth, so it's relatively colder there. But because of the weak gravity, the hydrogen atoms can extend to very high altitudes, and many of them will escape the weak Martian gravity. This may be a clue as to how Mars has lost a large amount of water over its history, and if we can understand what is controlling the escape of hydrogen today, then we hope to be able to extrapolate back in time for both Mars and Venus and understand the history of water on those two planets.